on page 271. So we're not going to do both of these because we just did one at the beginning of class here. But if I asked you to solve A here, I said solve for x. These are exponential functions because they're variables in the exponent. How would you solve for x? What's your first step?
Base 2.
Make them both base 2, right? You look to see if you can make them all the same base. So you're going to get this. And then once the bases are the same, you're like, just equate the exponents. C at x is equal to 3. Correct? That's what you just did on the questions that we did at the beginning of class. Now, obviously, that is your go-to method. It is the easiest method. It is the fastest method. Okay? Less likely to make mistakes. We're not going to do the second one, but when you get a question where you have variables in the exponents, exponential functions, you look at all the bases and you ask yourself, can they be made into a common base? And if they can, that's the way you want to do it. What if you have something like this? 2 to the power of x is equal to 50. Can 50 be made into base 2?
No.
Cannot. So we have to use a different technique. Okay? So when they cannot be made into a common base, you have to use logs. All right? So there's no common base. Therefore, logs. Okay, I'm going to show you 2 ways to solve a problem that looks like this, because these ones are the most basic type. So I hate how they do everything here for you. But 2 to the power of x is equal to 50. I need the variable in the exponent. I need the exponent to come down. I don't want it as an exponent anymore. The only way we know how to do it, well, there's 2 ways. We know how to do that, but they both involve logs. First one is this rule, the power rule, that says if you have a log of an argument that has an exponent, I can bring that exponent down in front. And that's what they've done here. They log both sides, right? They just write log in front of both sides. It's like what you do to one side, you have to do to the other side of the equation. So if you log one side, you have to log the other side. Now, you don't have to, what base is this if I don't write a base? Base 10. You don't have to use base 10. You could use natural log as well. I could have gone ln of 2 to the x is equal to ln 50. It doesn't matter. Okay? Why would you choose base 10 or ln? What is good about those for most people's calculators? You can put it in a calculator, right? Now, some people here have the ones that'll do any base. That's fine. But every calculator would do natural log and base 10. So that's why we tend to use those. All right. Once you've got the log, then I can use the power rule, which says I can drop this exponent down in front. Like that. And that's what they did here. Okay. Now, even though it doesn't look like it, this is like a grade 8 algebra problem. Okay. If I gave you the equation x times 4 is equal to 16, what would you do to solve for x in this one? You divide by 4, right? You would go divide by 4, x is equal to 4. This is the exact same thing. Natural log of 2, or log base 10 of 2, is some number. It's a decimal, but it's a number. So we do the exact same thing. To isolate x, I divide both sides by the natural log of 2. So I get x is equal to the natural log of 50 over the natural log of 2. And if you're doing it with the logs base 10, let's write it down here. X is equal to log 50 over log 2. Okay. So now you're going to get into this whole, the exact solution and the decimal solution. All right. The exact solution is that natural log of 50 over natural log of 2 or log 50 over log 2. That is the exact answer. It's like writing 1/3. Okay. The decimal is when you put it in your calculator. So what is natural log of 50 divided by natural log of 2? Actually, don't even know it. 5.6438, blah, blah, blah. Who cares? At some point, you're going to have to round off. All right. So this is the decimal. This is the exact. Log 50 over log 2 is going to give you the same answer, 5.6438, a bunch of other stuff. Okay. So if you have an exponent, you can log both sides. That brings the exponent down. Now, there is one other way to do these straightforward ones when you have one number equaling another number. And what you can do is you can change to logarithmic form right away. So what's the base here? 2, right? So if I change this to logarithmic form, the x falls down, and I get log base 2 of 50. That is right. But you can't, unless you have one of the calculators to do any base, you need to change that using the change of base rule to enter it in your calculator. So if you were going to enter it in your calculator, you would go, I can pick any base I want. So I'll pick base 10. And then the base of the original becomes the argument in the denominator. So if you like that method, you can do that method. But in the end, you get to the same point. It doesn't matter. Okay? If I'm asking for a decimal, you're going to have to enter it in your calculator. You're going to have to use change of base rule anyway. We okay with that? All right. Now we're going to practice them on the backside. So flip the page, please. Okay, number one, what do we have to do here? We have to do 3 decimal places, and we want the exact solution. So A, what do we do? What's the first thing you ask yourself?
Common base.
Can you make them a common base?
Yes.
Yes?
Oh wait, no, I'm doing this.
Cannot make them a common base. You cannot make a common base. So if you can't make a common base, you have to use logs. Do you want to use base 10 or do you want to use natural log? It doesn't matter.
Oh,
Base 10. All right. So log both sides. All you do is you write log in front. It's your first step. Then what? Drop the exponent down. Next step.
Divide log 4.
Divide off log 4. That is your exact solution, log 12 divided by log 4. So that gives us this bit. They want the answer to 3 decimal places, so you're going to have to punch that in your calculator, and I don't know what that is. 1.79? 792. That okay? All right. B. 8 to the power of x plus 4 is equal to 40. What should we do first here? Move the 4 to the other side. Simplify it as much as you can. So I'm going to move the 4 over, so I get 8 to the x is equal to 36. Now what? Can you make a common base?
Wait, no, I'm thinking about 6.
I know. Cannot make a common base, so we have to
Logs.
log. Base 10 or natural log?
Let's go natural logs.
I like that, natural log. So we natural log both sides. You can write base 10, it's the same thing. Or it gives you the same answer, I should say. Natural logs are more elegant, I find. They flow. It's more organic. So I get natural log of 8 to the power of x equals natural log of 36. Then I drop the x. And then you divide off the natural log of 8. There's one answer. Punch it in your calculator, and you should get the other answer. I don't know what it is. Anybody know what it is?
1.723.
That okay? All right. Before we do the next two, because those are going to change a little bit, I'm going to get you to do just number 1, please. So let's look at, here we go, this one right here. 6 to the power of 3x is equal to 3 to the power of 2x minus 1. What's the first thing you ask yourself every time you get a question like this?
Common base.
Is there a common base?
No.
No, I'll give you a hint. None of these ones have a common base because that's the whole point of this lesson. All right? But on a test, there will be ones with common bases, and there will be ones that are not common bases. The hint is the multiple choice ones are the ones with common bases, right? Because they're multiple choice, so they're meant to be done quickly. You could grind it out by doing all this if you want, but you get the same answer. Okay, no common base. So what do? You only have one choice here.
Logs.
You have to log it. Because we don't have, in these ones, it was some exponential is equal to a constant. These ones are not that. There's variables in both exponents. So you can't just change to a logarithmic form. You have to log it. At this point, it doesn't matter what log you use. Base 10 or natural log. It's up to you. What do you want to do?
Let's go base 10.
Base 10. All right. Okay, now I'm going to warn you. Write small.
Oh boy.
That's an ominous warning, isn't it? What's going to happen is it's going to expand, and then we're going to bring it back together again. Okay? So, base 10, log 6 to the 3x is equal to log 3 to the 2x minus 1. Okay. Now what?
Bring the exponents down.
Drop the exponents in front. 3x log 6 is equal to, okay, this is where things change. When you drop the 2x minus 1 down, it is being multiplied by log 3. So you must bracket it. Okay, I'm going to do it in a different color so that it stands out. Yeah. So you need to bracket that because the next step after this is the log 3 gets multiplied into those brackets. Okay, so this log 3, because that's a constant, so we'd multiply it in. So now I've got 3x log 6 is equal to, and then the 2x gets multiplied by log 3, so you just get 2x log 3, and then negative 1 times log 3, so you get that. Is everybody with me?
Yes.
Did we lose? Any questions so far? We're all good? Okay. Now it's an algebra problem. Grade 12 math is over. It's got logs in it, so it looks weird, but it's literally an algebra problem. It is this type of problem. If I gave you, or I'll just write over here because it doesn't matter. If I wrote 3x is equal to 2x minus 4, what would you do to solve that?
X is on the same side.
You would get all the x's on the same side, right? Correct? So I'd move this 2x over. I'd end up with 3x minus 2x is x is equal to negative 4. That is what you do. Get everything that has an x in it to the same side. Okay? So I'm going to move this 2x log 3 over to the other side. So now I've got 3x log 6 minus 2x log 3 is equal to negative log 3. Are we good with that step? All right, if I had this, I can't think of an example that will illustrate it. That would make sense. All right, we're trying to solve for x. We have multiple x's here. I cannot combine these. These are not like terms. This is the log 6 and this is the log 3. So you can't put them together. What is the only thing you can do to make two x's turn into one x? You do it in grade 10 and in grade 11, you do it all the time. Starts with an F. See that big F it right there? That doesn't mean the other F it. It means factor it. Okay? If you don't know what to do, you factor. So we can factor an x out of here. So I get x comes out. I'm left with 3 log 6 minus 2 log 3 is equal to negative log 3. Everybody okay with that? This is important because you will do it on almost every question. We're good? All right. How do I get x by itself?
Divide.
Divide. If I had 2x is equal to 4 and I want x by itself, I divide by 2. This thing here is just a constant. It looks gross because it's got logs all in it, but it's still just a constant. So divide it off. So you get x is equal to negative log 3, 3 log 6 minus 2 log 3. Okay. All right. For math 12, that answer suffices. Okay, that's the exact solution. Now, I'm going to show you how to clean it up a bit, but this is the right answer. On a test, you can stop there. Okay? But we're going to make it look a little better because the book will do it this way. So just to compare your answers. All right. If you have a number in front, how do you get rid of it on a log? Or where can you move it? Yeah. So we can use the power rule. I can move the n up. So what I'm going to do is I'm going to move this 3 up and I'm going to move that 2 up. So then I get negative log 3 over log 6 cubed minus log 3 squared. Anybody know what 6 cubed is?
216.
So and 3 squared is 9. If you are subtracting logs, what are you doing with the arguments? You're dividing them. Anybody know what 216 divided by 9 is?
24.
24. So you can write it like that. Negative log 3 divided by log 24. You could even move the negative up to the top if you wanted to. So you get 3 to the negative 1, so it's log of a third. There's a whole bunch, like, you can keep simplifying and simplifying and simplifying. but this is fine. Okay, this is on a test, you can stop here. Okay, the book will put their answers like this form. All right, so just so you know, but you can always check your answer by figuring out the decimal of the book and the decimal of what you got. So let's just do the decimal because it's good practice, and I will ask for the decimal answer on a test as well. What is the answer in decimal form? I don't actually know it, so I'm gonna have to do it. Negative 0.3. Negative 0.345. Everybody else agree with that? Please practice putting it in your calculator. You will be asked to do it on a test. And if you don't give me the decimal answer when I ask for it, you'll lose a mark, even if you did everything right. Okay? All right. That procedure is basically what we're going to do from now on for these types of questions. So let's do another one. This one here. Okay, 2 times 3 to the x minus 2 is equal to 7 to the x. So, what's the first thing you ask yourself? Can they be made into a common base? But the answer we know is no. Okay, so what do? You throw log in front of everything. Okay, are we doing natural logs? Are we doing base 10? Do you care?
Base 10.
I don't want to do base 10. All right. I like natural logs. I'm doing natural logs.
Aren't they the exact same thing?
Yes. Well, they're not the exact same, but it gives you the same answer. All right. I'm doing natural logs. Okay. I do. You guys never learned handwriting, did you?
Well,
Do you learn handwriting in school now?
Oh,
Really?
I did, but I never used it. I
Nobody
learned
does.
it, but not in school.
Okay. Now, what do you want to do? This one's got a trick in it.
You
cannot drop the x minus 2 exponents because the x minus 2 is only on the 3. Okay? What you have to do is you have to separate the 2 and the 3. Now, they're being multiplied. If they're being multiplied, that's the same as adding. So this now becomes, before you can drop the exponent, natural log of 2 plus natural log of 3 to the x minus 2. I can drop this x over here because there's only a 7 there, so I can just write x natural log of 7. And now I can drop the x minus 2 because we have the argument isolated. It's only one argument in there. So I get natural log of 2 plus x minus 2. Please bracket it. Times 3 is equal to x natural log of 7. What do we do now? What do you have to get rid of? Brackets. You got to multiply the natural log of 3 into the brackets. So this has to go in here. Okay. Now everything's expanded. There's nothing with brackets or arguments stuck together or anything like that. What do we do? Silence out there. What are we trying to solve for? X. So you have to get all your x's to one side. Now, it doesn't matter which side you move them to. What would be the smart move here?
Moving the x along 3.
Yeah, move this over here because it's one move, right? If I move, I could move the x natural log of 7 over here, but then I got to move these two terms to the other side. All right, so you might as well just make the one move. So the x natural log of 3 goes over, and I get natural log of 2 minus 2 natural log of 3 is equal to x natural log of 7 minus x natural log of 3. And then what? What are we trying to solve for? X. But I only want one x. Right now I have two x's. So what do I do? Factor an x out. Divide off the natural log 7 minus natural log 3. And for math 12 on a test, you could stop there. Just a note, if you moved everything to the other side, okay, you would get this. You'd still have the same tops and bottoms, but they're going to be flipped, the order and the signs. So you would get 2 natural log of 3 minus natural log of 2 over natural log of 3 minus natural log of 7. That would be if you, instead of moving this x over here, move that and that and that. Okay? These are going to give you the same answer. So in the book, if you have this, but the book says this, so everything is the same in terms of top and bottom, but the signs are flipped or the order's flipped, that just means they moved it to the other side. But it's the same answer. If you punch them into your calculator, you get the same answer. Just because we're here, can we clean this up a little bit? We'll do this one here. How can I combine them to make it a little more concise? Move that 2 up.
Sorry, did you say you were gonna ask for something like that on the test?
No. On a test, you can stop at these 2 points.
So how come we're doing this?
Because the book will do it that way. And if you go on, nobody leaves it like that in math. They cleaned it up. Because that's just kind of, you can make it a little simpler. So I move that 2 up, and I get natural log of 2 minus natural log of 9, natural log of 7 minus natural log of 3. And then the only other thing you can do is, because they are being subtracted, that means you're dividing the arguments. So you would just write natural log of 2 over 9 divided by the natural log of 7 over 3. That's about as far as you can go. And if you did the orange one, the fractions would have been flipped. If you did this one, you would have gotten natural log of 9 over 2 divided by the natural log of 3 over 7. Everyone that has a circle or a box around it is the same answer. It's just rewritten in different form. Okay? Any questions? Check to see if it's a common base. None of the ones you're going to get today are common bases, but it's a good habit to get into. Log both sides. Drop the exponents, but only drop the exponents once you have arguments by themselves. Okay? Don't drop them at this stage. You got to separate them and then drop. Get all your x's to one side. Get everything else that doesn't have an x to the other side. Factor out an x. Divide off. And that's it. 3 to 4, please. And I think that'll bring us up to the